This is an example for a one mean hypothesis test. So the prompt, a tech study was done claiming that phone batteries last an average of 30 hours. I'm just going to underline the word claiming. I know that's important. G-Mobile took a random sample of 27, so here's my random sample, of their batteries and found they lasted 33.9 hours with a standard deviation of 9.8 hours. Do these data give convincing evidence that G-Mobile batteries last longer with significance alpha equals 0.10? So here's what I'm going to be comparing it to. This is what will tell me if I should reject or not, so that significance level. So I'm going to start out by just identifying the important information. So the first thing I want to know is, what is my sample? So how many am I looking at? So I'm going to go N equals, and my sample is 27 batteries. So I'm going to put 27 batteries. If I were to write this down as a population, it does not get a number. Instead, it gets all batteries. Let's look for the statistics. I want to know what's the average amount of time it lasts and the standard deviation of that sample. So the average hours for the batteries, 33.9, and the standard deviation, 9.8. The parameter, what am I looking at? I'm looking at the true mean hours for the batteries. So because it says evidence, so I'm looking for convincing evidence, and they told me a significance, that's how I know this is a hypothesis test. They also claimed something that I need to test and prove if they're actually accurate. So I'm going to come on down and I'm going to do the HAND procedure because this is a hypothesis test. So I need to know, what are they claiming? What are they claiming is my null hypothesis. So I'm going to put HO. And then I'm going to look at that sample and see if it's going to be any different and by how much. So let's go find out what their claim is. A tech study was claiming their phone batteries last an average of 30 hours. So an average of 30 is going to be my claim. So what I'm going to do is I'm going to put mu equals 30. We're dealing with means, and a claim is in mu. Now notice I'm still in my hypotheses. My mu has to match. My number has to match. What makes the hypothesis different is am I going to put a greater than or a less than sign? So we're going to come on over and we're going to look at the actual question. Do these data give convincing evidence that G-Mobile batteries last longer? That longer would give me that greater than sign. I can also look and see that 33 is bigger than 30, so I should be using the bigger than sign. Your hypothesis is good enough as long as you've written out all this information. You don't need to make this any more complicated, and you can leave your hypothesis like this. The next part of the process is checking our assumptions. They may give us all this data and they may want us to test it, but unless it meets our conditions, we don't want to keep going. So let's just make sure that all that data is good enough. The first thing I want to check is if it's random. So I'm going to look for somewhere in the prompt where it mentions random. And right here, G-Mobile took a random sample of 27. So I'm going to put random sample. I need to check to see if it's independent. This means that I'm not taking too many from my population. So I'm going to want to know, what is that N value? And I want to make sure it's less than 10% of the population. We are looking at all batteries. Well, I'm sure there are lots and lots and lots and lots and lots of batteries at G-Mobile. 10% means let's add a 0 at the end of that number. So 27. If I add a 0, that's 270. Do I think there's more than 270 batteries? Heck yes. So I can definitely say 27 is less than 10% of all batteries. And again, this is the letter N. Next, I need to check for check for normal condition. Normal condition means I have enough data to assume that that curve is going to look normal. For a mean, I need to make sure that my N, the total number I'm looking at, is greater than or equal to 25. We looked at 27 batteries. 27 is larger than 25. All of my assumptions have been checked. I can move forward. So the letter N is for name and number. So let's go through how to name it. First, how many samples do I have? I have one sample and one letter N. So I'm going to put 1 for one sample. Is this a mean or a proportion? Well, I have mu's, so this tells me it's a mean. I also have the word average in my prompt. Next up is, what letter is this? Is this a T-score or a Z-score? Well, T for tigers, because tigers are mean. Whenever we're doing means, we're doing a T value. And because we're going through the HAND, we are doing a test. So this is a one mean t-test. Now I need to set up the formula for finding the t-score. To find that, I'm going to take the our x bar minus the mu all over the standard deviation. And I need to put those into numbers. Now here's the only problem. They didn't tell me standard deviation. They told me the letter S. So we're going to have to work this bottom out a little differently. So here's what it's going to look like. My x bar is 33.9 minus my mu, what they're claiming is 30, all over. And now we're going to create a fraction on the bottom. We're going to do, so this turns into Sx over the square root of how many we took. So my standard deviation of the sample, 9.8, divided by the square root of how many were in my sample, 27. This is all the work you need to show. And what I do is I plug this into my calculator. And I'm going to go ahead and show my calculator screen. When I do this in the calculator, my t-score ends up being 2.0679. And I'm just going to write all of those because I have them. And it gave me the p-value of 0.0244. So let me show you how to get that p-value if you don't have a calculator in front of you. And that's going to require a table. They will provide this table in the AP exam as well as in your textbook at the very back. So here's my p-value. What I'm going to do is grab the table that you would normally get on the AP exam. There's a lot going on here. So how many were in my sample? 27. We always go up one. So we're going to be looking at the 26th row. Now, what was my t-score? My t-score is 2.06 when I put everything into my calculator. So I'm going to go down the 26th row to get as close to 2.06 as possible. 2.05 is the closest I'm going to get. If I go all the way up, my p-value is going to be close to 0.025. So start at 27, go up one. Find that t-score, or as close as we can. Now let's figure out what that p-value would be, 0.025. Let's see if I got close, 0.024. So we can use the table if you don't have a calculator that'll do that for you. So we know the p-value, and we also know the significance. Now we need to make a decision. So I'm going to go back to that graphic so you can see what I'm going to be talking about. What this is telling me is this line right here is where I landed. This is my 2%. This is my p-value right here. But the shaded area in red, That's that 10%. That's the significance. Notice I landed in the red region, which means I'm going to be rejecting. So let me write that out in another way. My p-value is 0.02, and my alpha, my significance, is 10. The p-value is smaller than the 10. So if here is my 10%, my 2% is going to land inside the rejection region. So if I need to make a decision, I'm going to say, do reject the null. And the null was that I would be equal to 30 hours. So I'm rejecting that I am 30 hours. I reject it because this is telling me I do have evidence. Remember, do's go together. Do have evidence that, and now we're going to look at the ha portion, the alternative. I have evidence that the average is bigger than 30, that the average battery hours is more than 30. So because I landed in that rejection region, I'm going to reject that it equals 30 and that I have evidence that it's more than 30. And that's how we complete the full hypothesis test for one prompt. Please use this video to help you with your example on Desmos.